Hello algorithmicians, we are going to go through some examples of Turing machines in this video. Just a nice opportunity for you to practice following the instructions. They are taken from this book, which I just got for like less than $5 on Kindle. It's not all entirely relevant to the algorithmics course, but it's quite easy to read and has some nice background information. So worth having a look. All I'm going to do is run through these Turing machines on the 3 tapes that have been given to you, and while we're doing it, try and work out what it is that these machines actually achieve. So, and I'll also pause the video and try it before I go through it. So we start in state 0 on this one here on the first tape. First one is 1, so we move 1 to the right, and we're now in this state. Then we go 0, move 1 to the right, stay in that state. 1, move 1 to the right, stay in that state. Now we have, sorry, 1, move, lost sync already. 1, move to the right, stay in that state. Now we have a blank one, so we move to the left, and we are now in this state. And we have a 1, which puts us in the accept state. Now these halting machines are a bit different. They have, instead of just halting, they have either reject or accept. So this one has 2 outcomes basically, nothing to worry about. So this one we end up accepting. Okay, let's try the next one. We start on state 0 on the left hand item. We have a 1, which means we move to the right and move into this state over here. We have a 0, which means we move to the right. And you can see we just keep moving to the right in that state until we hit a blank one. Then we move to the left, which puts us here. And because we have a 0, that puts us in the reject state. And machine stops. Let's try the last one. We start on 0 in this state. We go down, this time we go to the bottom state. We move to the right. Then we keep going along. We stay in this state down here, moving to the right each time until we get here. We hit the blank square. We move to the left, and we are now in this state. And because we are on 0, we move to the accept state. Now, what does this Turing machine do? You might be able to have a reasonable stab just by looking at the examples, but let's look at the first state. We either do 1 or 0. So if it's a 1, we move up. If it's a 0, we move down. And then in both cases, we just keep cycling along until we get to the end of the string. Same thing on the bottom, cycling along until we get to the end of the string. And now if we're in the top branch, we look at the penultimate character, or the last character before the blank. If it was a 1 on the top branch, we accept. If it was a 0, we reject. So this top pathway, to end up with accept, we had to start with a 1 and finish with a 1. And by a similar argument on the bottom, we had to start with a 0 and finish with a 0 to accept there. So what we ended up doing is accepting any string that has the same digit at the start and at the end. And we don't care about what's going on in the middle. That's Turing machine number 1. Turing machine number 2, again, try and work through it yourself and see if you can work out what it does and what the answers are. We start on the top tape in Q0. We see a 1, so we move to Q1 and we move to the right. We see a 0, so we stay in Q1, move to the right. Another 0, stay in Q1, move to the right. We see a 1, which means we move to Q2 and we move to the right. A 1, which means we move back to Q0 and move to the right. And then we have a blank, which means we move to the right and we accept. So this one, we end up on that thingy and we accept. Let's look at the next one. I'll leave that there. We start on 1 here. So that 1 makes us move to Q1, moving 1 to the right. The 0, we stay where we are we stay in Q1, move to the right. The 1 means we move to state Q2, move to the right. The 0, we stay in Q2, move to the right. Another 0, stay in Q2, move to the right. The blank, we move to the right, and we are in the reject state. And finally, we start in Q0 on 0. That first 0 does nothing. We stay where we are. Then we have a 1, which means we move to Q1, moving once to the right. That extra 1 means we move to Q2, moving once to the right. The 0, we stay in Q2, move 1 to the right. This 1 puts us back in Q0, move 1 to the right. The next one, we move 1 to the right, and we are now in Q1. The next one puts us in Q2, moving 1 to the right. The 0, we stay where we are. Sorry, that 1 means we move to the right. It's quite easy to lose count with these. And then from here, the 0, we stay where we are, we move to the right. We have a blank, and so we end up in accept. And that tab would be in the next cell there. Okay, so how is it that we end up in accept on the first and the last and reject in the other ones? Hopefully you might be able to have got the feel for this. Every time we have a 1, we cycle around this triangle. 1, 2, 3, 1, 2, 3. And the only way we can end up in the accept state is we need to be in Q0 when we get to the end of the tape. Now the zeros don't affect the states. The zeros just let us move along. Every time we hit a 1, we move around the 3 states, Q0, Q1, and Q2. And so we have to have a multiple of 3 number of 1s. The number of 1s must be a multiple of 3. So we go, start here, we go 1, 2, 3, 1, 2, 3. And we should end up there if we have, so for example, on this bottom one, we had 6 1s, which made us go from here, 1, 2, 3, 1, 2, 3, and then from there, we ended up in the accept state. And you may have seen it's quite easy to lose sync of where am I in the diagram and have I moved along one. So be very careful with that. Okay, the next one, I'll probably just need to explain this. We have these extra characters which call marked zeros and marked ones. There's no reject or accept state, but we would say that the machine crashes if we're in a state and there's no transition defined for that input. So I'll show you what we mean when we get there. So we start on 0 and we start here. This line here means we turn the 0 into a marked 0 and we move to the right. So we're now here in state Q1. And you can see now we keep moving to the right until we hit a 1. So we end up here in we're in Q1, we see the 1, we mark that 1, we move to the left, so we're now here, and we're in Q2. We have 0, so we move to the left, still in Q2. We have 0, move to the left, still in Q2. Now we have the marked 0, which we leave as a marked 0, and we move to the right, and we're now back in Q0. The 0 there becomes a marked 0, and we move to the right, so we are now in Q1. The 0 stays 0, and we move to the right. The marked 1 stays marked 1, we move to the right. We are, really get rid of those. 1 here becomes a marked 1, and we move to the left, and we are now in state Q2. Marked 1 stays marked 1, we move to the left, still in Q2. 0 stays 0, we move to the left, still in Q2. The marked 0 stays marked 0, we move to the right. We are now in state Q0. Oof, this is exhausting. 0 becomes a marked 0. We are now in Q1 on this one. Marked one stays the same. Marked one stays the same. We end up here. And at this point, it crashes because we're in Q1 and there's no defined blank cell. Okay. So we can just put crash. Okay. Let's try the next one. The next one, in fact, crashes straight away. So we start here in Q1, in Q0, and yeah, there's no one, so that doesn't work at all. The next one, we start at Q0 with a 0. We mark it 0. We move to the right, putting us in Q1. The 1 then puts us, we mark the 1. We move to the left, and we're in Q2. The marked 0 moves us 1 to the right. We're back in Q0. The marked 1 here, we move 1 to the right. And we're in Q3. And once again, we crash because there is no 0. So you can have a think and try and find a tape which will work. You can actually tell, I mean, if this had been a blank, we would have been okay. So if we'd had like this, then it would have worked out. Okay, last one of these to try. Now, if you're looking at the tapes and you're looking at the, we're looking for an obvious pattern, your first guess here might well be correct. Now, I'll see if we can do this in 3 minutes before my time limit is exceeded. We start in Q0 on A, and we change that to a blank. So I'll just scrub that out. We move to the right, and we are in Q1. Then we have a B, which moves, and you can see what happens from Q1. We just keep cycling along until we hit a blank, at which point we move back over here, and we are in Q2. Now, this was an A, so it becomes a blank. If that was a B, it would have crashed. So from here, we move now to the left, and we are in Q5. If we have a B, that becomes a B, and we move to the left until we get a blank one. And then we end up back in Q0. So what you can see we've done is scrub out the first and last A. If that last letter had not been an A, then it would have broken. And we're running out of time for this, so I'll just have to tell you, this will work. This will accept for even numbered palindromes. So if you work through these, you'll find in fact all of these reject, because even though the first and the third are palindromes, they're odd numbers of letters, so it won't work. It needs to remove, and it will keep sort of recursively removing the first and last letters of each string as long as they are the same. So hopefully that was fun, bit of practice working through Turing machines.